We're going to go through section 5.3, which is applying probability rules. So just to kind of go through some formulas. So depending on where the event is, it can either be in a row or a column. I'm going to go through kind of the steps to find these different probabilities, just to remind you. So if I want to find the probability of something that's in a row, I'm going to take the sum of that row. So let's say it was row 1. And then I'm going to divide by the sample size. So that's going to give me the probability of the row. To find the probability of the column, wherever that column is, let's just say it's column 2, I'm going to take the sum of that column. So I'm going to add up all those values in the column and divide by the sample size. Sometimes they'll give you the sum or the totals. Sometimes you have to add it up yourself. If I want to find the probability of the row and the column, what I'm doing is finding the value where the row and the column meet. Okay, so I'm looking at where do they meet, so where does that highlight overlap? That's going to be my numerator, still divided by the sample size. If I'm looking for the probability of the row or the column, I'm going to take the sum of the row plus the sum of the column minus the value where the row and column meet. And again, that's because this was counted twice. In our totals. So it was counted here when I highlighted the row, and it was counted again when I highlighted the column. And so I have to subtract one of those away because it's not actually in there twice. Still divided by the sample size. So let's look at this in an example. So executives for a company that prints logos on products are expanding the company's services to include souvenirs such as hats, shirts, and foam fingers for sports teams. The data they collected for a sample of 300 adults, so this is our sample size. Remember that that is what's going to be our denominator. About their favorite sport to watch and their favorite souvenir to buy are shown in the table. And so the sports were football, baseball, soccer. And again, they talked about the hat, the t-shirt versus the foam finger. So let B be the event that someone prefers baseball. They want us to find the probability of B. So baseball is this row. So what we're going to do is we're going to divide the total for that row by our sample size of 300 adults. So we want to add up those values, 39 plus 66 plus 21, which gives us 126. So they might let us have that as an answer, right? So it might have 126 over 300 as an option. It might want it reduced, which this reduces to 21 over 50. Or it might want it as a decimal. So if I evaluate 126 divided by 300, it's about 0.42. Okay, so you want to look at your options for your answer choices to determine how you're going to write your answer. And then let T be the event that someone prefers a hat. Oh, that should be an H here, sorry. Let H be the event that someone prefers a hat. So hat is a column, and so we're going to look at this. So remember that our numerator is the sum of these. So if we add those up, that equals 120. So it's 120 over 300. And so 120 over 300 reduces to 3/5, which is 0.40. Okay, for the next one, they want us to find the probability of B and H. Okay, so and remember, is where they overlap. Okay, so and means that my numerator is going to be where they overlap, which was 39, still divided by my sample space, which was 300. And then again, I don't know how they're going to write the answers in my options, so it might need to be reduced, which that can reduce by 3 to be 13 over 100, which is 0.13. And then when we're finding the or, we're actually using all of the values from the previous step. So remember that the probability for an or is still going to be over the sample space, but it's the total for probability of B. So B was 126 plus the total for the people that preferred a hat. So plus 120 minus the people that got counted twice, which were the people that prefer baseball and a hat in general. And so that adds up to 207 over 300. Which I can reduce that by 3 as well, is 69 over 100, which is 0.69. Okay, the last two we're using complements. So for complement, remember that that means that I'm going to do 1 minus the probability of B. Okay, so instead of this, the complement is everything else. The probability of B was 0.42. So if I do 1 minus 0.42, that's going to give me 0.58. So the probability that someone does not like baseball is 0.58. The probability of B and H complement, remember, if I think about this, is the probability that they like baseball, but they don't want a hat. They don't like a hat. So really what's happening here is that it's the other two values from the table. So if they like baseball, but they don't like a hat, I'm going to ignore the hat value. So it's going to be 66 plus 21 divided by 300. So if they like baseball, but they don't like hats, it's going to be 66 plus 21 over 300. So that's 87 over 300. I don't know why I just wrote 21, I'm sorry. Which reduces by 3 to 29 over 100, or 0.29. The other way that we could do this is it could be written as the probability of B minus the probability of B and H. Okay, so instead of just adding up the two that didn't like hats, we could have taken the whole probability, the 126, and subtracted the 39 divided by the 300. And we would still get that same answer of 0.29. Okay, so in the next example, we're filling out a two-way table. So I wanted to go through that process because they don't really do that in the examples. You use it, but you don't really fill it out. So a survey of 500 college students moving into their dorm revealed that 425 brought a microwave, 380 brought a video game console, and 50 brought neither a microwave nor a video game console. A survey participant is randomly selected. Let N be the event that the participant brought a new microwave. And let C be the event that they brought a video game console, organize these events into a two-way table, and then find the probability that a participant brought a microwave or a console. So our goal is to find that. So we need to know the probability that they brought a microwave, a console, minus the probability that they brought both. Okay, so let's fill in what we know. So the survey was of 500 college students. If I have the total value, that's always going to be this last box in a two-way table. So my columns, they brought a microwave or they didn't bring a microwave, right? So the complement means they didn't bring a microwave. I could write also no or something, whatever you kind of want there, but they are complements of each other. They brought a video game console or they didn't, right? So no console would be an alternate way for you to write that. You're not submitting the table, so it doesn't really matter what you title them. And then I included the total columns because that's what they gave us. They gave us that 425 brought a microwave. So they're giving us this whole total here is 425. They're also giving us the total that 380 brought a video game console. So video game console, 380. Then they tell us that 50 brought neither a microwave nor a video game console. So no microwave, no video game console, 50 people. That's going to go where those two titles meet. Okay, so I filled in the table with everything that I was given in the problem. So what I need to do now is to figure out what the values are for each of the missing pieces. So I'm going to start with the totals. So if the total of 380 plus something is 500, I'm going to do 500 minus 380 to find this value here. So that means that 120 people did not bring a video game console. I'm going to do the same thing here. So if I subtract 500 minus 425, that's going to tell me how many people did not bring a microwave. And so that's 75 people. Notice that now that I know those totals, I can figure out how many people didn't bring a microwave but brought a video game console. So if 75 people total didn't bring a microwave, 50 of those people didn't bring a console either, that leaves me with 25 that must have brought a video game console. And so then if 380 people brought a video game console and 25 of them didn't also bring a microwave, if I subtract those two numbers, that's going to give me 355 that brought both a microwave and a video game console. And then the final number here we've got that didn't bring a console. I really have two options. So I can either do 425 minus 355 to get this, or I can do 120 minus 50. They should both give me the same number, which is 70. Okay, so now that I have my two-way table, I can find the OR. So remember, to find the OR, I'm going to add up the total for my column plus the total from my row minus the total of where they overlap, which is 355. Okay, so the total is the numbers at the bottom. I don't even have to add because it's already been done for me. So 425 plus 380 minus 355 divided by my sample size. So remember that that value there is my sample size. So divided by 500 is going to give me 450 over 500, which reduces to 9/10, which is 0.9. So again, I don't know which of these is going to be the correct answer because it's multiple choice. So you're looking for ultimately that. So this formula ultimately leads us into the general addition rule. So the general addition rule is that if I know these probabilities, I don't have to know the actual values in the sample size. If I know the probability of A, the probability of B, and the probability of A and B occurring at the same time, then I can add the probability of A plus the probability of B and then subtract the probability of them occurring at the same time. So remember that the probability of A and B is this intersection. So the intersection is denoted by that upside down U shape. So that's all outcomes that are common to both events. Whereas the union, which is a U shape because the word union, is the OR probability. So that's this guy. So this whole total is our union. So it represents everything that's in both circles. So for the last example, we're going to go through the Venn diagram and filling that in. And then we're going to find the probability of A and TC, T complement. Okay, so I'm going to fill in all of the values. This is just asking us for the value for one, but we're going to fill in for everything just so you can get that practice. So travel agents collected data from recent travelers about their modes of transportation for their vacations. They found that 37% traveled by airplane. Okay, so they're telling us that probability that they traveled by an airplane is 0.37. 8% traveled by train. So the probability that someone traveled by train is 0.08. And then the probability that they traveled by both was 7%. So probability of A and T is 0.07. So this piece represents 2. So this 0.07 is the overlap of event A and event T, okay? And so the rest of these we need to figure out. So what that means is that this chunk of the Venn diagram, so this moon shape, represents the probability that someone rode an airplane and didn't ride a train. Okay, so this is the one that's going to be the answer for this question. So that means that it's the difference between these two values. So it's 0.37 minus 0.07. So that's 0.3. So that's actually going to be our answer to the problem, but we're going to go through and fill in the rest just so that you can get that practice. Okay, so then we're going to do the same thing for the other side. So if I'm looking at this side, if I know the whole circle is 0.08, then the probability of T, so the probability they took a train and didn't take an airplane is going to be where they're not overlapping. So that's going to be 0.08 minus 0.07. So that's only 1%. And then finally, if I think about the rest of this space, so the probability that they didn't ride a plane or they didn't take a train is going to be 1 minus the probability that they rode in an airplane or a train. And so remember that the probability they rode in an airplane or a train is that whole sum of those values. And so that's going to be 1 minus, so 0.3 plus 0.07 plus 0.01 is going to be 0.38 if I add those together to get that percentage. And then that means that the rest of the sample space is 0.62. So for down here, 0.62. Okay, so that's looking at a Venn diagram and being able to fill in the pieces using the overlap of the events to kind of guide yourself through the rest of this. Remember that what I should always check at the end is, does 0.3 plus 0.07 plus 0.01 plus 0.62 should equal 1? And if it does, that tells me that my probability distribution is correct.